This is Fan of Astronomy, episode 11.
10, 9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Welcome all to the first installment of a period of, I think, 4. We'll find out as we do them. Leaning towards 3 of Jupiter. This is Fan of Astronomy. I am the host, or one of the hosts, or something like that. My name is Angelo, and I am joined this week, as always, by Mr. Don Horning.
All right, that was a new one. Yeah, hi there, Angelo. I'm Dan.
I was trying to get your name right.
Yeah, Don Horning.
Don Horning. Okay. Yeah. Oh, well. You know what? You should speak English.
Yeah, I'm trying to.
Good to hear you're alive.
Yeah, I'm happy too. I have to talk about that a little.
I figured you probably should. You almost, you didn't almost die. You was in a bad world for a brief period, but luckily you left Earth. Explain it as a listener.
I live in 2 places. I have this villa in a small town in the north of Sweden, and I have an apartment in the smack dab middle of Stockholm. And when I leave my apartment, I walk out on the biggest walking street of central Stockholm, Drottninggatan, the Queen's Street. And it goes to the government and to the castle of the king. And this street is very busy with people walking. There's already been 2 terrorist attacks on the street. But on Friday, the 7th of April, somebody drove a truck down the street, trying to hit as many people as possible. And due to some very brave people were warned in advance, and only 4 people died. But this crazy hell ride with a lorry started right outside my door in Stockholm at 2:53 in the afternoon. All week I had been in Stockholm, and I walked down the exact way the truck took 20 times. It's like my regular route I walk whenever I do anything. But 4 hours before the attack, I left for the north. So that was pretty good timing.
Yeah, I know. I was legitimately concerned when I saw it come over the newswire. I was like, oh, wait, whoa.
So right outside my fucking door.
That's scary.
There are 2 ornamental concrete lions at the street corner. And one of them got knocked to the side. And then there are ornamental street lions. They weigh 1,800 pounds, these lions. And the truck just moved right over them and threw them along the street. One hit a concrete window further down the street, and one hit a beggar on the street.
So these things weigh almost a ton, and it just ignored them.
Yeah,
wow.
The lorry weighed 15 tons. I was driving at 50 miles an hour.
Just for the American listeners who might not know, a lorry is basically a tractor trailer.
Yeah, that's the British word, right? I thought I knew an English word. The truck in English, in American English, I guess.
Yeah, in American English, we call it a tractor trailer.
And its target, the terrorist, was aiming at the big square at the end of his ride, where there's a lot of people. But a guy driving an armored transport blocked the way. So he took his armored transport and put it in the way of the truck. So the truck driver chose to hit an apartment store. So he just drove straight into a department store and survived and actually got away. But the cops got him 8 hours later.
Well, that's good that they caught the guy.
Yeah, so there's,
It's terrible that he did it, but it's good that they caught him. Is it being considered as terrorism as we know it, or is it inter-country type?
No, it's the guy was the guy who is arrested is from Uzbekistan and is a radical Muslim.
Okay, so he said ISIS or something?
Yeah, it's getting blamed on ISIS, and it's probably correct.
Well, I'm glad you're safe, Dan, even if it meant that I had to finish these notes and do the show.
3rd terrorist attack on my street in Stockholm. That is in 45 years, but still.
I'll tell you what, if there's another one in the next couple of years, I think...
Yeah, I am actually moving, but I have to wait a while because prices need to go up again.
I mean, being that close to Parliament, realistically, you're kind of in a target.
Yeah, it's like I live at the other end of the street, but it's up a hill, so it's a great place to start your crazy truck drive.
Yeah, you got to gun it at the bottom of the hill so you still have steep at the top.
It's like probably a kilometer or more to the government. So if they had just bombed the government, I would have been safe.
Unless all that rubble came rolling downhill on you.
Yeah, but the government is down the hill.
Oh, okay.
Okay, back to Jupiter.
Yes, well, before we even talk about Jupiter, what we need to talk about is Patreon.com.
Yes, patreon.com/astronomy. That's our Patreon. You know how Patreon works by now. If you like what we do and want us to do it even more, please become a supporter at patreon.com/astronomy. You commit to $1 value per episode, like $1 or $2. And then if we make episodes, you give us some money, like Kickstarter, but for recurring content.
Yes, it's amazing. You should absolutely do it, because if we reach the combined goal of Patreon, we are going to do a special episode that will not stop our bi-weekly. That should be pointed out. Episode. It's just a bonus episode, and the first one is going to be all the different that space does not want us to be here, and why we shouldn't actually be here at all. So I think that's an interesting episode. I think all of you should want to hear it. You know, if you do want to hear it, if 100 of you want to hear it, just give us $1. Give us $1 an episode, and then we'll all of a sudden do that. So it's great. So there's that. But today we're going to take a trip to the largest planet in our system. This world is really the thing that holds the entire system together. Without it being exactly where it is, we can assume life itself on Earth wouldn't. Today we're going to talk about the fifth planet of the sun, obviously the king, Jupiter. In this episode, we are mostly going to ignore its 67. Yes, 67 moon. We're going to ignore the possibly thousands to hundreds of thousands of Trojans that it has. That's not a joke. That's a real number. We're going to try to stick directly to the planet itself. Don't worry, there's still a lot to talk about here, and we're not even going to be able to cover it all. First, though, we need to get the boring facts.
Nothing is boring about Jupiter.
Well, I mean, okay, so let's just start right here. It is what is considered a gas giant.
Yeah, quite a quintessential gas giant. It's made mostly of hydrogen and helium. And then we have liquid metallic hydrogen, which is a strange beast deep inside it.
Yeah, you need very pressure to form liquid metallic hydrogen. It's almost impossible to get here on Earth. Like, you have to expose hydrogen crazy shit to get that to form. The second our atmosphere hits it, it's going to just...
Very true. There is also something deep inside Jupiter. It should have a molten rocky core, sort of like Earth-like, pretty much in its composition. But and the reason it has to have that is that something need to have been there to gather all the hydrogen in the beginning of the solar system. But the exact nature of this rocky core is mysterious to us today. And a small little spacecraft we'll return to in episode 3 called Juno is currently orbiting Jupiter. And one of its missions is to figure out more about this rocky core of Jupiter.
And hopefully it actually does, but I'm going to be honest. We're going to talk about this a little more in depth, like he said in the series. I'm not really thinking that it's going to get to... I'm not high on it. Just put it that way. Yeah, I just... It's also, we should talk about this huge gas giant being exactly, or around about, 5 points from the sun on average.
Yep.
So, I mean, it's got some distance.
Yeah, the sun's energy decreases with the square of the distance. It gets 1/25th the energy on a certain area compared to the Earth. Yeah, so the sun is fairly weak out here.
Yeah, but you know what's strong out here? Jupiter.
Yeah. Jupiter is very, very strong. The gravity well of Jupiter is enormous.
Yeah, so Jupiter kind of does its own thing. It does its own heat. Now, it does take it almost 12 years the sun, approximately 11.
Yeah, but the Babylonians figured this out in 400 BC.
Yeah, when you're that far out, though, yeah. You're that far out, it's going to take a while. You figure, we've said in the past, it's the further you are from the sun, the bigger you are.
Yeah, it's a pretty quick orbit compared to some we will talk about in future episodes.
Absolutely. The days differ on this planet, which is kind of weird, depending on exactly where you're at.
That's super weird.
The day at the equator is about 10 hours long.
That's some pretty fast winds.
That is the fastest day cycle of any planet. that is any currently recognized
Yes.
within our solar system. However, if you're at the poles, a day takes 5 minutes.
Yeah.
So it's spinning faster at the equator than the pole.
Is the difference that small?
Yeah, it's only 5 minutes, but still, I mean, if you present that over a year's time,
Yes.
that 5 minutes adds up a lot.
Yeah, and you also have the effect that you can't really stay at one spot because there are strong winds going in different directions on different areas of Jupiter.
Yeah,
so,
there is.
Yeah, your perception of a day, if you were at the surface of Jupiter, defined as one bar pressure, right? There is no surface; it's gas.
Yeah, which is why this is why this whole thing is possible. But it actually it creates a bulge at the equator. Like, this is not a perfect sphere by any stretch of the imagination.
You were looking at Jupiter the other day, right?
Yes, I was.
Can you see the bulge?
I can't on my telescope.
Is it like Saturn or? Okay.
No, I can't on my telescope. I can see the eye.
And you can see the moons, the Galilean moons.
I can see two of them.
Cool.
You know, but they're really faint. But I could see two of them the other day. Again, you know, there might have been one in front, and Jupiter just kind of hit it, and there could have been one behind it for all I know. You know what I mean? I don't know their exact location, but when I was looking at it, I could clearly see two of them.
Nice.
Now we need to talk about how big this.
Oh yeah. Yes, we do.
And there's a lot of different ways of saying how big it is. Surface area, that's equal to about 121 Earths. That's a lot of size. What about the volume there, Dan?
Well, it's equal to 1,321 Earths. You could fit many Earths inside of Jupiter.
Yeah, many. The mass, and we know that, you know, we've already talked about how massive the Earth was.
Yep.
So, I mean, like, by far, just has so much density. Well, this has the mass of 307 Earths. Just think of it this way. You could take all of the planets, combine them, and you would get and it would still take 2.5 of the other 7 planets shoved into Jupiter to make one Jupiter.
That's pretty big. There is a very telling picture I've seen. If you put like 10 Jupiters in a line, you get the diameter of the sun. And if you put 10 Earths in a line, pretty much you get the diameter of Jupiter. So the size difference between Jupiter and the sun is about the same as between Earth and Jupiter. So Jupiter is enormous.
Yeah, it's really big. So by now I'm sure you noticed that Dan said that Jupiter was made up mostly of hydrogen and helium. And that literally is the same thing we said the sun was made up of. So could Jupiter be a failed? Well, it really depends on how you look at it. In a quick answer, you can say yes. But if you go a little deeper, you find it real. So let's really dive into what exactly a star is, if we should consider this.
All right.
Okay, so for Jupiter to become a star and reach ignition, we need about another 75 to 80 Jupiters.
Yeah, that is if you want hydrogen fusing into helium on a regular basis. If you get like 12 more Jupiters into Jupiter, you get the deuterium for merging into helium. Then you become a brown dwarf. Yeah. But in order to become a red dwarf, which is a real star, you need 75 to 80 Jupiters. And we don't have 75 to 80 Jupiters, so in that way it's nowhere near a star.
No, it's not. And the funny thing is, say we were, after we get that 75 or 80 masses of Jupiter, nuclear fusion is going to... Here's the funny thing about that. Jupiter wouldn't get any bigger.
Well, that's so weird, but it's true.
Gravity would make it compress, and most likely what would end up happening is Jupiter would actually get smaller if we added more mass.
That's crazy.
Yeah, it's just like, it should be that, you would think the more stuff you add to something, the bigger it gets, but this thing is at about the max that it can get under its own gravity.
Yeah, it's the maximum size for a planet, which is kind of interesting. The heat from Jupiter comes from it's compressing under its own gravity. And if it had more gravity, if it had more mass, this would be more efficient, making it smaller. So if you look at the hot Jupiters that are often much bigger than Jupiter in other solar systems, they are generally a little bit smaller volume-wise than Jupiter.
Yeah, odd.
And if it eventually would ignite, if you put in 70 to 80 Jupiters, fusion would start and that would increase its size, but not by much. The smallest red dwarf stars are about 30% bigger in diameter than Jupiter.
Yeah,
so
once you start getting around, you adding that 65th or 66th Jupiter into it, it would start expanding in size a little. But for the first 60-some, it's going to shrink.
That's so incredibly weird.
Yeah, it's like, the more I read about that, the more I'm just like, yeah, that makes absolutely no sense, but these people are physicists. I'm going to...
If you like to see that happening, you should watch the movie 2010, where the aliens just give Jupiter 75 to 80 more Jupiters in mass, and it becomes a red dwarf star.
That would be catastrophic.
No, it actually didn't do very much. It was their intention was to help life on Europa, and that's probably what would happen. So a red dwarf star at that distance is not a catastrophe.
Wait. You put that much more mass out. So the gravity of that, you're telling me it would not rearrange the inner planets at all?
No, the sun is still so much bigger. So everything still stays stuck to the sun. I think the main belt would go away for certain, but yes. I think Mars is safe.
Okay. If you say so, I'll go with it, but I have to wonder about that. I have to wonder if it would start to suck Saturn in.
No, Saturn is way too far out.
Yeah, but they already kind of pull on each.
Yeah, but if you look at these red dwarf systems and their planets are really close. So Jupiter's system of moons is quite similar to red dwarf's solar system.
Okay.
In many ways.
Wait. How do you get 75 to 80 masses there without creating havoc, just getting them there?
No, you probably have to do what the aliens did in 2010 and teleport it in.
Oh, see, now we're just talking impossibility.
Yeah, we're talking science fiction. So in that way, Jupiter is not close to being a star. It's sort of made up of stuff that stars are made up of.
Which all of us are.
It's nowhere near. It's not going to turn into a star anytime soon.
I mean, we're all made up of star stuff. It's just...
Yeah, I meant star stuff like the sun.
Yeah, it's made up of the same stuff that a star would be made of. It's nowhere near big enough, so it's not worth even calling it failed star. You will have some people argue that. Hey, do what you want.
As you said, if we try to bring that mass in, we'll wreck the solar system for sure.
Yeah, so it's not a failed star, but who cares? It's still amazing. One of the most remarkable and well-known parts of Jupiter is a little feature we like to call the big red spot. We all have seen pictures of this huge thing. It's so big, in fact, that with a 6-inch telescope, and I can confirm this, you can see it from Earth. I saw it just this past week on my scope. For anybody who's listening, you can literally see Jupiter all month in the night sky, at least in my hemisphere. But
we're in the same hemisphere.
Yeah, very, very good. So I just, point mine to the south. There it is. Bang. So go ahead. If you want to look, you can look. Located on the southern hemisphere, the spot is actually a super hurricane, and it is the size of a couple.
Yeah, I got this great picture I will probably use for this episode. Or somebody superimposed the Earth on top of the red spot, and that gives you a pretty good impression of its size.
Yeah, if you do that though, because of the color, it looks like kind of the eye of a storm because it's still bigger.
Yes.
You can fit 2 to 3 Earth diameters inside of it. That's.
It's super big, and the strange thing is that it doesn't go away.
No, its actual size it ranges. It has shrunk, it has grown. It's currently, but it's 24,000 to 40,000 by 12,000 kilometers.
Wow.
We first saw this thing when?
Well, the first confirmed observation of it was from 1831, but there is a 1665 observation that could be the same red spot.
Probably is.
And that's very close to the first time we really looked on Jupiter through a telescope, so I think it could be thousands of years old.
That is the thought. There are 2 other spots extremely close to this.
Yeah, there are some white and brown spots all over Jupiter, but they are significantly smaller, although they also are enormous.
Yes, they are. In fact, a few of those white spots that you just talked about, they formed a second giant that we often call Red Spot Junior. It's actually Oval BA, and they formed together just a few years ago.
Yeah, that is super interesting. Now we're going to see for real how long this will last.
Right.
But it is changing, right, Oval BA?
Yeah, Oval BA is growing.
Yeah, maybe it'll turn into the same thing.
It might. The actual red spot that we're going to talk about, though, it has sustained winds at the edges of 225 miles per hour.
That's a nice edge to have. Like, nothing is going to get past that.
No, that would like rip skin off very easily. And we have gusts in that same area of 270 miles per hour.
So it's a windy day on Jupiter always.
Yeah, so what would that be in kilometers? 440 kilometers?
Yeah, something like that.
That is fast.
That is pretty fast.
The fact that it's red, that comes just from the intensity.
We have some mathematical models showing that this may be a permanent feature. And I read somewhere that it could be like an outlet for hot gases. Hot gas rises up, and this is sort of the place where hot gas leaves the inner parts of Jupiter.
Okay.
So that's what fuels it to go on. So Jupiter needs this kind of outlet.
What would happen? Would it become a star?
No. Not that hot a gas.
Right. Strangely, though, it's shown that shrinking, I brought up, it's actually lost about 15% of its size in the last decade. And if trends continue, this thing might actually become round in 2040.
All right.
Yeah, right now it's kind of oval because it's too big to be perfect round, apparently. But if it loses some of it would look round, more like our hurricanes here on Earth.
Imagine this hellish place. It's like a storm going on that loses 15% in 10 years, so you don't even know if it's going to end. It's like still just happening.
Yeah, right. It could lose up to 30% by I want to say it's 30%. And, yeah, it's still going to be unreal big. Still at the size of the Earth. Big.
Insane. Yeah. It also, I read somewhere that it moves much slower than the rest of the winds or the bands on Jupiter. So it takes 6 days for the red spot to go around Jupiter.
Right. But I think that is kind of a sign of just the storm, because like storms here on Earth, the way they track.
Yeah.
They track from east to west, typically around the equator.
Yeah.
And so they're tracking against the natural spin of the planet itself. So it makes it seem slower as far as a day goes.
Yeah, and it shows how strange it is to envision things on Jupiter, because as there is no surface, there are no like spots you can focus on. Everything is moving.
Yeah, but the fact that there's no surface is one of the reasons this thing has gotten as big as it is.
Yes.
You know, like think about what happens to a hurricane when it hits here on Earth. This thing has no land to hit.
No, so just go on.
Perpetually. It's unreal. I mean, holy crap, these are big. You know what else is big, though, Dan?
A lot of things.
It's magnetosphere.
Yes.
It's roughly about 14 times stronger than our own. It's so big it protects its 4 biggest moons within it from solar wind. Now, we get ours from a molten iron core. Jupiter's is created a little bit differently, since there really isn't any iron on Jupiter that we know of. Explain this to me.
If there's iron, it's in the core, but it's definitely not enough to do this. It's the liquid metallic hydrogen stuff that interacts with swirling conductive materials. And a lot of Jupiter is this liquid metallic hydrogen, which enables the planet to create this enormous magnetosphere.
Yeah, and these conductive materials actually come from one of its moons, Io, who spits out the sulfur dioxide with its volcanic eruptions, and the sulfur dioxide becomes ionized with solar radiation and makes it conductive.
Yes.
And it has what's called a bow shock area that is just absolutely just stupid big. Okay? Like the bow shock area actually like gets into the asteroid.
Yeah, the magnetosphere of Jupiter is the biggest object in the solar system that doesn't originate from the sun.
Right. And you want to try to explain kind of what the bow shock is? Some of the things that happen because of it.
As I understand it, it's where the magnetosphere encounters the solar wind.
Yes, it's exactly where the solar winds. And we have one of these here, and it's a neat thing that we call the Aurora Borealis. And there's actually southern lights too, but no one's. So the size of its northern lights just dwarfs them.
Yeah, it just dwarfs our planet. The northern lights on Jupiter are amazing. We'll post some pictures of them in the Facebook group for Fan of Astronomy. But it looks crazy. It looks like there's some intergalactic war going on.
Intergalactic war?
Yeah, it's like this blue light crowning Jupiter.
Oh, it's like Star Wars. Oh, yay. Pew, 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 pew. Okay, now we're going to move to the last part that we're going to talk about as far as Jupiter. And that's its ring. We all know about the wonderful rings around Saturn. Well, Jupiter has some. They're just not nearly as prominent, but they're there nonetheless.
Oh, yes, they are. Basically 4 rings. The halo ring, 2 rings named the main ring, or the Amalthea Gossamer ring, and the Thebe Gossamer ring. So that's 4 rings.
Yes, the main ring, the halo ring, 2 Gossamer. This is the 3rd planet that we discovered to have them. We know of 4 planets in our...
That is basically all the giant planets.
Yeah, right now, although we did talk earlier that Mars
might get one.
Yeah, in a few years.
Yeah, and if you look at Saturn, the rings are enormous. But in order to put it into perspective here, all of these 4 rings are within the radius of the Earth-Moon system. So the ring that is furthest out, Thebe Gossamer ring, it's closer to Jupiter than the Moon is to Earth. And it has a lot to do with the 4 regular inner satellites, the 4 small moons closest to Jupiter. So Amalthea is feeding the Amalthea Gossamer ring, Thebe is feeding Thebe Gossamer ring, and Adrastea is sort of doing something to the main ring, which we'll probably talk more about in the next episode.
And the halo itself, the halo ring, it's mostly just like dust. It could have been a moon that just kind of got apart. And
no, it's the closest one. It's very close. It's 92,000 kilometers from the surface of Jupiter.
Yeah, but
we don't really know how much is in the halo ring. The other rings are more well known because of the moons.
Yeah, I mean, these rings are, though, no matter how you look at them, they're mostly with dust. The main ring, however, is the brightest, and it's also the thinnest as far as actual size goes. So it's kind of weird, like, oh, there's a ring there, and the other ones are just huge. Like Dan said, the halo is extremely close to it.
Yeah, the main ring is probably the most interesting of them. It could have small moonlets and stuff, whereas the other ones are pretty much dust.
The 2 Gossamer rings are the ones but these ones are also the widest.
Yeah.
We believe that these rings have been created basically from impacts on the...
Yes. It could also be the result of Jupiter doing gravitational bad things to the moons.
Yeah, just like tearing them apart.
As Jupiter is bullying poor Io, but we'll talk more about that in the next episode.
Okay. So I'm sure you're thinking, wow, you guys barely scratched the surface of Jupiter. And
there's no surface.
I guess that's true, but you would be absolute. As we've stated before, this topic is way too big to try in one episode. We have something pretty in-depth coming in the second half of the show, so we had to, make cuts. But even after multiple episodes, we're not going to cover nearly as many things as we're going to ask you now. We would like to be out of the main solar system this year, so some concessions had to be made.
If you feel that there's something we should absolutely cover about Jupiter, please email us at, what's our email address, Angelo? Cast.
Wait, no, did I get that one right?
No, you got that wrong. So it's the wrong order, AOF.
Okay, AOFcast@gmail.com.
Yeah, so please tell us if there's something you really like us to cover.
Yeah, I mean,
we'll try to include it in episode 3.
We're going to try. And I know one of the that we left off of this that probably should have been in this was Shoemaker Levy 9.
Oh, yeah, we've got to talk about Shoemaker Levy 9.
That will absolutely be an episode 3.
Right now.
That is absolutely going to be an episode. So, I mean, we still have a bunch of stuff to talk about.
We also have some interesting collisions that have happened after Shoemaker Levy 9.
True. But we will come back in the future and go over some of the things, such as the multiple migration, its formation, and many other things. All that said...
that's probably its own episode, right? Because it's the whole solar system.
Yeah, this is a comeback to in the very long future. All that said, the next episode we will talk in depth about the Galilean moons and quickly go over the other 63 moons. Now we're going to take a real quick break, and then we're going to come back with a crazy theory that I came up with on what possibly dark matter...
Oh my, okay. Interesting.
Hello. Are you enjoying the show so far? I hope you are. Well, if so, I encourage you all to pause the show. Don't worry, we'll wait. Go to facebook.com/fan of astronomy and hit that like button. You'll be one of the first people to know when a new episode comes out. Also, on that page, the guys post articles on the latest news in the astronomy field and outer space in general. You also get to interact with the hosts of our show, Dan and Angelo, there, so please hit that like button on Facebook. Thanks.
All right, Dan, are you ready for this?
I guess I am.
Okay,
Let me know.
Look, I spent a few days in the last or so pondering dark matter and dark, like I do this a lot. I want to know what it is. Where does it come from? Why can't we see it? So after hurting my brain one day, I actually came up with a hypothesis. I'm sure I am way off and completely wrong, but I actually came up with a possible answer. I've done none of the math. I should state that right now. I can't show you my work. The thing is that ideas come hopefully somebody will take what I'm about to say and prove it correct or completely wrong. Then I can just go back to my little,
Before we do that, I'd like to say that I have no idea what your theory is, so I'm really curious right now.
Yeah, basically I kind of kept it off of, because I didn't want anybody knowing this until I actually said it. And the first thing that we have to look at is multiple different theories, okay, that have nothing to do with dark matter or dark energy. And one of them is time and perception of time. And what I mean by this is right now, you know that if you look at your watch, you can watch the seconds tick by, right?
Yes.
Okay, so let's say you're halfway to Mars and you looked at that exact same watch. Would the seconds tick by at the same time?
Yes.
Okay, but would they do that here with your watch that's out there?
So you mean I'm looking from Mars at my watch on Earth?
Yes.
Okay, then we get some time delay because of the speed of light.
Okay, no.
Okay.
Time actually just acts differently.
Yes.
Under different gravitational pulls and what have you. Such as, say I took Dan because he irritates me and I throw him into a black hole.
No, please don't do that.
Okay, so here's the thing. To Dan, going into said black hole, Dan is going to shoot straight through it.
Yes.
To you, because you're the one going through it, you're just going to zip right through, okay?
Yes.
To me, watching you zip through it, it will take an infinity amount of time for it to watch you fall the whole way in.
Yep.
Because I'm not being affected by the black hole distortion on time and space.
Yeah, that's why we call it an event horizon.
Yeah, so this is the perception of time. While time is a thing, time acts differently dependent on where you're at in the universe. So that's one thing, okay? And now black holes play a big part in, really cool, weird things that we know nothing about. Now there's lots of theories about black holes. One of them is that a black hole is a wormhole to another portion of
that would be nice.
Okay, this is one that is out there. Another black hole is that it literally will just crush you and nothing will come out of black hole whatsoever.
Yes.
This possibly is the correct one. However, there's this other one is out there that says that entire universe exists inside every massive black hole.
Is that a white hole theory?
That's the white hole theory. But the thing is, the white holes is where it's shooting out, but there's no mathematical equation that shows that that the black hole could just be containing the amount of mass that goes into a supermassive black hole, like you can begin to break it down mathematically and go, holy crap, there could be a whole.
Yeah.
Okay, so this is where I get to my theory of what dark matter and dark energy is. Now, we know that dark energy and dark matter exist. And the reason we know this is, as Clues aptly explained in episode 5, and that's about when that without dark energy or dark matter, under every computer simulation we've come up with, the universe would just fall apart.
Yes.
It cannot there. So, if you take all these theories and combine them, you come up with basically what I think probably makes no sense, but I at least thought was interesting, and hopefully Dan will walk me back off of this cliff. If not, I'm sure Clues will, because I already told him about this, going to listen. Or maybe some of our listeners will, but if there's a universe inside of an entire black hole, the perception of time says we can't see that black hole spinning from the inside of it.
Okay.
That could be creating the actual spin of this black hole that is housing our universe. You have to look at it as we are inside of a black hole right now.
Yeah.
Okay? Its spinning could be the dark energy.
Interesting.
And its dark matter is the actual makeup of the black hole. But because of time perception and what have you, we just can't see this because what we're looking at is the actual black hole.
All right.
Okay? You get where I'm at here. I know this is like quasi-complicated.
Yeah, my head is hurting.
Yeah,
Go on.
If you're looking at a black hole from the outside, you see the black hole, or at least you see the accretion disk around the black. But you can clearly tell that it's just a blackness, a darkness. So if that is obviously a certain size. It has bigness to it as far as our view from the outside. But
things we know about the black hole from the outside is the mass and the spin.
Okay.
Right.
But what if you're looking at those same things from the
Yeah, now my head is really hurting. Go on.
Okay, so if you're looking at them from the inside, now, as I said earlier, just looking at Dan going into a black hole is going to take infinity amount of time. We don't know exactly. We know that he would shoot through it really quickly and come out on the other side, but we don't know what we from the inside. So what we could be seeing is the actual makeup. The dark matter is the makeup of the black hole itself, and the energy is the rotation of the entire, which just likely holds all of the stuff together that's supposed to. And then this goes on and in because under this theory, every black hole holds its own, every massive holds its own universe.
So are you telling me that there would be a universe in every black hole, even the really tiny ones?
In every massive black hole, there would be a recognizable universe, and every small black hole, there should be. It depends on how much matter a black hole has swallowed in its lifetime.
Yeah.
And while its lifetime, and this is the thing about the Big Bang, while a black hole's lifetime may be extremely long to us out here, okay,
yes,
when we're looking at the one in the center of our galaxy, per se. Now, that looks like a really long time that black hole's been, and it's going to be. Okay, but that's us viewing it. As I said, when I throw you into that black hole, it takes an infinity amount of time for me to go into that. But you're going to shoot through it really quick. So, inside of that black hole, that infinity amount of time has already happened.
Yeah.
It's already sucked up everything it's going to suck up within its lifetime. And when it does that, bang, that's where you get a Big Bang from.
So you're saying that from within the black hole, you perceive some amount of the matter in the black hole as dark matter?
I think that all of the matter of the black hole is the dark matter. That is the black hole. That is what we are.
Yeah, because the first, are you done or?
I think so. I think that's the best I can explain it without making my own brain hurt.
Yeah, my brain is already hurting, but there are degrees in hell, and we know a lot about dark matter compared to what we know about dark energy. One thing we know about dark matter, I think it's pretty clear now that it has nothing to do with black holes. That black holes are made out of real matter, or at least partially made out of real matter. So because black holes interact,
right,
whereas dark matter doesn't.
Right. Okay, I get what you're saying, but once you get past the event horizon,
yeah,
the matter breaks down.
Yes, but it still remains.
It doesn't remain matter. No, it doesn't remain matter. It breaks down.
Oh yeah, it breaks down into something we don't know what it is, really.
Exactly. So why doesn't it break?
And the one thing we know about dark matter is that it has this problem interacting and it has mass.
Yes. That is the mass of the black hole looking inside, under my strange theory.
Interesting. When it comes to dark energy, I have just given up. I don't think I will ever understand dark energy. It's just...
There's just so much of it. That's why I say it's the spin.
So tough. Yeah.
I mean, look, again, I don't know if this is right, but after days of listening to different things, months of listening to different things, reading different, like this is just this strange off-the-wall thing I came up with that made enough sense to me that I felt like it was worth saying on a show. I don't feel like I'll be a...
I'm interested in hearing others' opinion on it. We'll come back to dark matter and dark energy in later episodes.
Oh, yeah.
Because there's a lot to say about it.
I mean, the thing about... Okay, so dark energy, we know there's a lot more of it.
Yes.
Than there is dark matter.
And that it causes the acceleration of the universe expansion, which is very tough to think about.
Yeah, right. Yeah. It's an unknown energized, it permeates in all of space. Okay, so this is kind of where I get the idea that if we're inside of something that is spinning,
yeah,
energy is being created by the, or not created, you cannot curse law of thermodynamics, but energy is there with the spin. First law of thermodynamics for anybody cannot create or...
yeah, and that's one of the problems with dark energy, because it seems to actually be creating energy from nothing.
Yeah, oddly.
And then now I got the idea. What if, like, dark energy is fueled by stuff that falls into the black hole, but that's way too irregular. That just something falls into the black hole some of the time.
Well, that's
dark energy is just constant.
But that's just it.
Yeah.
When things are falling into that black hole, from the inside, if the perception of time thing works the way it's supposed to, from the inside, while we sit there and watch stuff fall into black holes at irregular intervals for the complete life of said black hole, on the inside of that black hole, it's already happened.
Yeah.
Because, it's already shot through. See, you have to also kind of take it as, time doesn't work the same. All things that are going to ever happen or has already ever happened, happen.
Deep.
Right. You kind of have to take that with, from the inside of this black hole, that's how that is. So energy that's coming into the black hole has already happened. All the energy that it's ever going to suck up from the inside, looking out, it already did it.
All right.
So like when you say that it's not a consistent thing that makes it come in.
So that doesn't matter because it's not the same time.
Right. You're dealing with the different times.
Yeah. Okay, please email us davefcast@gmail.com or comment on YouTube and shoot this down. And Clues, please help us.
Yeah, I mean, look, if somebody could get me to quit thinking about this, because I've spent way too much time on it, I would be greatly appreciative. But this is the strange thing. I think it holds a little water.
It's two of the biggest mysteries in the universe, and they are definitely worth thinking about.
They are. That's the way I feel. Yeah, please help me out. If you're smart enough to do the math on it, which I doubt that there's too many people who could.
No.
Because I don't think they've never come up any math inside of them. Eventually, the event horizon, all was kind of. But I guess the way I can put this to make it kind of easier to think about is we know of the 4 forces
Yes.
in the universe, right? Which are gravity.
Yes.
The weak magnetic force, the strong strong.
I think it is the weak force and the strong force.
Weak force, the strong force, and then is
Electromagnetism.
Electromagnetism. Okay. So we have these 4 forces. So basically with this proposal, the inside of the black hole thing is right. Dark energy and dark matter are kind of a fifth.
Oh, I do have something on the inside of black holes, but I'll save that for the black hole episode.
Okay. Well, I mean, is it pertinent to what we're talking about?
Kind of.
Then say it.
Okay. We know that if you are close, if you are at the event horizon of a small black hole, 5 solar mass black hole, spaghettification happens and
Yes.
you die extremely quickly. But if you have a supermassive black hole, you are so far from the core of it that you could probably perceive the inside of a black hole if you pass the event horizon, because you are not immediately killed. You can never get out because gravity is so strong. But, and then I read this part, if you put 2 of these massive black holes close enough to each other, so their event horizons overlap, they have to be really big for this.
Yes.
Then they cancel each other out.
They do.
And that's the only way to escape from the event horizon. So you sort of cancel the event horizon with another event horizon.
And
if the holes are big enough, you could actually escape at that point.
And it's a very small window that you can do that, because if the 2 event horizons get that close to each other, one of the black holes will swallow the...
No, they could still orbit if they were big enough. But, of course, an infinite amount of time would have passed outside the black hole. So the world you come back to is not what you want.
No, it would be completely different.
Now we are out on really deep water.
Yeah, you would come back to our solar system being gone, possibly our galaxy gone, and another galaxy forming, our galaxy and Andromeda's collision, and
that's just the start of it. You will probably see the final end of the universe then, if it ends in proton decay or not.
Yeah, it'd be ugly. I don't think I'd want back out or got that close.
Suddenly Jupiter seems very easy to understand.
Yeah, it does, actually. Anyway, look, if you like this episode, please go to...
Hey, I have one more thing.
Oh, okay.
Jupiter is also an enormous radio source.
It is.
And sometimes it is brighter in radio than the sun is. And you can actually listen to Jupiter. So I figured we should put the sound clip here with something called an S-burst from Jupiter. And then we're going to end all the Jupiter episodes with different messages from Jupiter. So this is Jupiter giving us an S-burst. Okay, now you can end.
Okay, so look, if you like this show, I'm sure Dan's going to send me that so I can hear it, because I heard nothing.
I already have, actually.
Oh, okay. Go to iTunes. I hope it wasn't on one of the ones I erased.
Yes.
go to iTunes and hit that subscribe button. Give us the 5 stars, obviously, and comment. And if you do, we'll read that here. And if you go to YouTube, which is kind of Dan's realm, what should they be doing there?
They should comment, like, and subscribe.
So basically the same stuff, just not 5 stars. You just hit thumbs up.
Yes, much easier.
Yeah, and Google Play, kind of the same deal. However, there's a setup. If you can find us on Google Play. Lord knows, I heard we was approved directly from Google, and I've never been able to find our show on there.
Google Play is still illegal in Sweden, so I can't listen to it there.
Yes, but please, comment, let us know what's up, and we will absolutely read those on the air for you. And you can also, talk to us on the Facebook group, which is facebook.com/fan of astronomy. Join the group. We try to post 2 things a day. Dan, for some reason, doubled up my post this week.
Oh, yeah, it was important.
It was very important, apparently. But we try to, talk about 2 different things every day so you guys can, have different things to fuel your science mind. And we're pretty good about it. I miss occasionally. But
yeah, I'm very much into Planet 9 and Kuiper Belt stuff. New target for New Horizons.
Yes.
Yes.
That was the thing that I posted that you doubled up on. I was like, dude,
okay, well, super important.
I literally just posted this 6 hours ago. Why is he posting the same thing?
Coordination, anyway. It's hard.
Yeah. Anyway, if you there's other places you can get a hold of us also. Dan, if people wanted to get a hold of you, where would they do that and how?
You can do so on Twitter, where I'm Dan Horning. You could put 2 small dots above the O and find me on YouTube or Facebook as well. I do a video blog every day for 2017, and for day 97 and 98, I talk about the terror attack in Stockholm.
Yeah, I watched that one.
Where can people find you?
You can find me on Twitter at 2 different addresses. One of them is FOA Angelo. I do occasionally post there, and I'll respond to anybody who chooses to talk to me. You can also find me unfiltered and just being a regular jackass over at Gonksuo on Twitter. That's GANKSUOU. That's where I tend to post random stuff that has nothing to do with science. Like if I put a garden in today, I would post, hey, I built a garden today in my backyard. So that's where you'll find that crap. That's more a personal me thing, where the FOA Angelo is more the science thing. So next week we're going to, or I'm not, I gotta quit saying that next week crap. In 2 weeks on our next episode, we are going to go over the moons of Jupiter.
Oh, yes.
We're going to go over the Galilean moons, which are the famous ones.
Yeah, I got shut down for wanting to do a separate episode on Europa, but we'll talk a lot about Europa and the other ones.
Yes.
So Callisto is really boring.
We're going to focus on the big ones. We're going to talk about some of the inner ones, and then we're going to quickly talk about the other ones, because 67 moons, if we gave every one of them 2 minutes, you're looking at a 2.5 hour episode. And that has...
Gotta talk about my favorite S2003 J2.
Gesundheit.
Gesundheit.
I mean, it doesn't even have a name yet, man.
It's interesting that they are all named after Jupiter's lovers in Greek and Roman mythology.
So who's SJ?
No, they ran out of lovers.
Well, they need to...
Jupiter was fairly, had a lot of girls, but he didn't have as many girls as Jupiter has moons.
Promiscuous. So wait,
yes.
One of them is named after like Hercules' dad? Or Hercules' mom?
I think so, yes.
Yeah, Jupiter is named after Hercules' dad.
Yes.
Yeah, because Jupiter is Zeus. If you know,
oh yes.
If you didn't cross that out there, that's how the mythology. Anyway, look, come check us out in a couple of weeks. We're going to talk about other stuff. We're going to talk about the moods. But please, keep looking up in the space. And remember, all month you can actually see Jupiter in the month of April. So please keep looking up. Maybe you'll learn something, but you'll always be surprised at what you can see.
What'd you think? Did you enjoy it? Well, if you did, head on over to patreon.com/astronomy and pledge to these guys. For each patron they receive, the more they will be incentivized to improve the show. So help them out so they can help you out and throw them a couple bucks an episode. They will really appreciate it. Thanks.